Today, we are talking about string manipulation. This is, again, the last sort of core skill set required to use R. This is understanding how to examine strings, which is a very common sort of data type if you're working with open-ended responses, which is where this will kick in the most. You can do things like we're talking about today to do things like search through focus group response or search through transcripts for specific topics and get information about those topics. There's a lot of very practical applications in kind of real-world business places where you might need to do string manipulation. So that's what we're covering. I've gone ahead and written in the RStudio API code, and I did, in fact, run it. So that, again, same as every time, so no surprises there. Data import on line 5, and then line 6 and line 7 is where we're going to start. So one of the things that's going to start happening, and happened here as we go through more projects, is I'm going to leave it a little more ambiguous as to what you need to do. So in this case, when you saw import anything you need, you don't know what you need yet, so you would probably start after that. Create the text file, or convert the text file citations.txt into a vector of strings. So that's actually a little bit easier. Yeah, I can't open it here. That's a little bit easier because I explicitly told you to convert it into a vector of strings, but you might still try to open it in a text file just to see what it looks like. I did describe this for you before. There it is. I did describe for you what this file is before. It's basically just citations, one after the other. Huge list. This is, I mentioned last time, every article that has ever been cited by any AI psychologist that is currently teaching in an AI psychology program. So there's quite a lot of citations here in a variety of different formats. One of the things that I hope you noticed, by the way, as we move forward, and why I bolded it, was this assuming correct APA style piece, because that's super critical to this assignment not being insanely frustrating. So we will get there in a minute, though. But if you look at this file for now, what you notice is that every line is encased in quotes, and otherwise it's just text. There are no data. There's no other points in here. So this is just the text file. You could potentially try to interpret this as like a CSV type thing, but if you used read_CSV or you used read_delim, you probably had to use a lot more code to get it to work than what you should have done. It works. It would be functional if you got it to work, but it would be harder. You may use _CSV or delim. No. What did you use? There we go. So that's in the which library? Stringy library. And then we're going to do a real simple import function, citations, and let's see, here we go. stri read lines, and then we're going to do our relative path to data, citations.txt. One of the things that's unique about this assignment that we haven't had before is that this is a real big file. This is not big data territory yet, of course, but this is getting there. If you're accustomed to working with 50 case data sets, this is probably pretty large. You'll notice that it imported as a large character vector. I mentioned last time that it imports as that instead of as a traditional kind of string, which is fine. But 9.5 megabytes in size is a lot of text. So line 8 is create a new vector called citations. Oh, I didn't import that right, did I? Oops. Create a new vector called citations text that contains only non-blank lines. How did you do that? Like that? Yep. This is by a good margin the easiest way to do that. There are a number of different possible approaches you could have taken, but yeah, this would have been a lot easier than the others. I just mistyped that again, didn't I? TXT. Okay. So, by the way, if you've ever seen me do this, I don't know if I've ever actually explained this. RM stands for remove. All RM does is removes it from the workspace. So I'm just clearing out variables that were not actually, I made that variable by accident, so I just got rid of it. It doesn't actually do anything else. It's just to keep that list clean up there. All right. So there, very straightforward. If we look over here, we can already see the difference right here, 56,000 to 45,000. But line 9 requires us to print the console the number of blank lines eliminated. How do you do that? Blank. Mm-hmm. Oh. Oh, yeah, you did it. I see. Yeah, that's the same basic idea. So, yeah, this would be the most ideal way to do it. Just printing out the difference in lengths. Key here, what I was making sure that you understood is the difference between the various length functions, because if you used strlen here, you would get a whole vector of differences, and it would not have been what you were supposed to get. So to get an actual single number, you have to use length. Length is the length of a vector. strlen is the length of a string. All right. So line 11 is data cleaning. We're starting to get the fun part. Import any additional libraries you need. This is another of the situations where you might have worked forward and kind of retroactively determined what you needed. I'm going to go ahead and tell you that what I used, which actually might not be the same for everybody, is stringer as well as tidyverse, as well as rebus. Might use something different. There's actually many different ways you could have approached this part. But these will give us the core of what we need for the piping, number 1, which is going to be, which I don't, is going to be most of our kind of dplyr function here. You could have imported dplyr, that would have worked too. And you could have imported magritter because you need, no, maybe you could have. Actually, not sure. Anyway. Tidyverse could have been one of several things. Stringer you definitely need, though. And rebus you might or might not have used. So who did raw regular expressions? Is anybody? Ha ha. Yeah, I would not have attempted that, personally. That's way harder. I'm going to show you rebus, and I'm going to reverse engineer what those rebus expressions look like as regex, because that's just more straightforward. If you did raw regular expressions, though, this gets really complicated really quickly, especially the last question. The last question in particular for raw regular expressions is really complicated. Even for rebus, it's pretty complicated. So, we'll go through them one by one, though. Where'd it go? Line 15, using sample, display a random draw of 10 citations to the console. You may want to run this command several times to get a sense of what the citations look like in the file. So if you've seen sample in DataCamp several times, but we've never explicitly talked about it. So you might have needed to take a look at the help file. If we all it does is it takes a random sample of some number. Actually, this one's sample n. Takes a random sample of something and basically however many you want from it. It does it based on a uniform distribution, so every item has an equal chance of being drawn. You can also specify whether or not you want to sample with replacement or not, which doesn't really matter for our purposes here. So we're just going to sample from Citations. What are we sampling from? Text. We're going to look at 10 of them. So this would have given you just kind of a snapshot of the kind of things that are in this file. In this case, we're seeing mostly APA style, correctly formatted. That's not universally true, though. Actually, anything? Oh, see, there's one that's not APA formatted. This did require that you know APA formatting. So, man, I hope you understood it by before now. Because the specific location and positioning of parentheses and periods and commas and everything else changes the kind of patterns that you can search for here. You'll also notice there's actually several things incorrect about this one. You'll notice we have this guy right here is not surrounded by parentheses. This is a comma instead of a period. This is a letter, the word and instead of an ampersand. You also notice some variation in questions between these guys in legitimate APA citations. Some of these have no space between initials. Some of these have spaces. Some of them have multiple authors. There's just a lot of little features to keep track of in terms of creating your rebus expressions and capturing as many as you can. I will tell you now that as long as you made a good faith effort in more or less getting them, then that is a good answer as far as we're concerned. You can really easily spend a lot of time trying to perfect a rebus or regular expression. If, for example, I had not given you the instruction to assume APA style, you would have to, what you basically do in real life, quote unquote, data science, is go through, create those matches, then randomly sample and make sure everything looks right, and then when it doesn't, create new regular expressions for each general category of a badly formed citation or whatever else it might be. And you repeat that process over and over and over and over again until you get 99% or more of everything you're trying to capture. So that, when I've done citation regular expression stuff before like that, that can take, just days straight of coding, working through all the various permutations that you can have. Here, it's fairly straightforward, where we're ignoring the formats that look like this entirely. That basically just leaves small variations in article sites, and it also leaves variations, I'm going to keep running this until I see one. Also leaves variations in book chapters and books. So those are the two things that you kind of need to look out for. I will tell you also that when I was designing the assignment, I spent way too much time on this, but went through basically every single piece of that citation to figure out what was the hardest and the easiest pieces of it, and scrapped ones that ended up being way too hard. So one of the most difficult, for example, are going to be any time that you have just plain text somewhere in the middle of something. So you'll notice I had that you were asked to get first author here. Well, first author means that you can do a lot of really convenient things like look for the beginning of the text. Anyway, so we go to 16. Using appropriate library and function, create a new tibble called Citations Table containing 2 columns. One called line, which contains the line number, and cite, which contains the citation text that you just imported. So how do you do that? Mm-hmm. Mm-hmm.
Line equals sequence or seek on the length of citations ext.
Yes, that will work. I'll give you the easier way to do it, which is that. Sequence does the same thing. Yeah, still right.
And then cite equals citation.
There we go. Easiest case. So all we're doing at this point is creating a brand new tibble. Back when we did this in the early parts of the course, that would have been data.frame or maybe data_frame if you want to do it without using tibble. But we're just basically creating that base tibble. I'm going to go ahead and keep this open in another tab just so we can see what it looks like as we work on it. This is a way that I would really strongly recommend that you do this kind of parsing so that as you're building a McGritter pipe, you just keep referencing back, does it look like what I think it looks like? So, okay. So we've got a brand new... Okay. So we are at line 17. Okay. So, a lot of very important instructions in this line. We have assuming correct APA style. We're starting a series of pipes. And we're also converting any extracted text to an appropriate type. So those pieces are all important to what you're trying to get out at the end here. So we have line 17. So remove all quotation marks, including double and single, from all citations. So how would we do that? Mutate. We're going to use a lot of mutates. What are we doing next?
Cite equals string replace all. Parentheses, cite, comma, pattern. Okay, equals C, parentheses, fixed.
Oh boy.
Yeah. Single quote, double backslash, quotation mark, single quote.
Double backslash, single. Wait, what?
Double quote.
Double quote. Okay.
Comma. Double quote, single quote, double quote.
Comma, double. Okay, I'm gonna stop. So.
It works.
Yes, I'm sure it does. That sounds like a difficult way to do it. Does anybody have a super easy way to do it? Anybody do that? That would have done it. So I mentioned in that last class, this is one of my hints and nobody took it. In this namespace document, what you should do is if you use Rebus is just search for things that you think are right. So what you could have done at this point is said, all right, well, what's a quote? If you look for quote, you'll notice that up quotation mark is the only thing that has the word quote in it. So then you might have gone back and said, well, let me create an example of that and see what it does. So you might have done like string replace, and I'm going to say a quote, and then I'm going to replace it with up quotation mark, and I'm going to replace it with nothing, and it worked. And you might have tried that even with a couple of different examples of that if you wanted to see what kind of quotation marks it actually took or did not take. Oops. You'll notice that what it does is it actually pulls out all quotation marks. And then you could have just used that. So that's why Rebus is super helpful. But you got to check the namespace. That's why we spent time looking at that. This namespace document, anytime that you're like, this is a weird symbol that is not a normal symbol, how do I represent it? Look through this first. This, oh yeah. This is from the Rebus GitHub. So I looked GitHub. Yeah, I talked about it, but I didn't actually give you a link, no. So if you go to GitHub for Rebus, then, wrong Rebus. We need Rebus for regular expressions. There it is, regular expression builder something. If we go into this GitHub, you can find all the documentation for how Rebus works. And then there's the file right there, namespace, which has the list of all the exported constants. And the other way, of course, you can do it is with Rebus : and then scan through the whole list. That's a little harder with quotations in particular because it starts with up for some reason. And I'm honestly not sure why it starts with up, but yeah, it does. So you would have found it in that list also if you'd scrolled through. But yeah, otherwise you would have to use, yes, either a series of fixed quotation marks or an individual quotation mark, since, again, if you go into Citations Table and you look, you would have noticed that you only have double quotes. There's no other variation on that. So you could have just used a fixed double quote. That would be the other easy way to do it. Unicode really just refers to a universal strategy to refer to any non-ASCII character, but also to ASCII characters. So ASCII is which is the, actually, yeah, those are them right there. ASCII, ASCII, is a very old standard for what is represented as text. It communicates to a computer like how you know that something's a letter and not a number. And there's something like 250 different characters, I think, in regular ASCII. But so what Unicode is for is to say, well, what if you want to have something in text that is not one of those 200 and whatever characters? So Unicode is a way to refer to literally anything. And that's why we can have emojis, for example, in text messages, because the text message, instead of sending one character from ASCII, it sends the whole Unicode string. So everything can theoretically, though, be represented in Unicode. There is a Unicode representation of every character. So you don't, I wouldn't, what all that is to say, you don't use Unicode or not as a distinguishing feature. You would use ASCII or not in ASCII as a distinguishing feature. So quotes are ASCII, which means they could be represented either raw or as Unicode characters. So it doesn't matter. Yeah. The other way that this would work would be that. This statement would also be a simple version of this. Yeah, fixed universally just takes whatever's inside it. So if you did like sometimes when people do fixed, they try like that instead inside of fixed, but then you're literally sending a / quote, and so that doesn't exist in the file, so it wouldn't catch it. The safest, see, this is where you get into weird places with regular expressions. So the safest way to do that then would probably be that. You couldn't do it as fixed though, so you would do up quotation mark. Yeah, and you could do it as two of those. You could do a begin rebus up or in a quotation rebus end or start. Is it begin or is it start? I always flip this. Start, isn't it? Yeah, start. So you could do start rebus up, or you could do start rebus up quotation or up quotation rebus the other. And actually, you could do that in an or. So you could have done it like up quotation mark rebus end comma. Yeah, that I think would work too. Yep, there we go. That would be the safest possible way. So then it's only the beginning and the end of the string. Any of those are fine for in here. Okay, let's keep pushing though. So I'm going to go ahead and pipe this in. I hope that you also see the advantage of piping in this context, because you can completely re-import the table every time that you add new code. That's, again, one of those real advantages of using the gritter and using pipes. So we don't have to constantly scroll back up here and re-import the file and then come back down and rerun it again. All right. Line 18. Create a new variable called year. So we're going to mutate again. We're going to call it year. What are we going to use here, though? We're going to match. We're going to match the site, and we need a rebus expression. Open paren. Capture. Digit. 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 Oh my goodness. And digit. Yep, in capture. Oh, yep. Bracket, comma, 2. There we go. And we have years. At least the first part of that. There's still one other thing we need to do, but that got you most of the way there. What other thing do we need to do? Yep. Oh.
So you close the 2 bracket within that.
Mm-hmm. So let's pull this out just so you can see what it's actually doing. Okay. Well, that's that one. So what we have is we have a year. We're encasing everything coming out of string match inside the as numeric. So that means we have to as numeric that column, not the full results of the string match. Because the full results of string match, remember, is a matrix. So that can't be used in this context. So we have to put in, we have to put it inside the as numeric, but outside the string match. And remember, always think about it in terms of returns. This string match function, again, returns a matrix. So you can just imagine from string match, open paren, close paren to not exist. It's just a matrix. Then we subset that by the second row, and now we have one column which goes into as numeric, and then that one column goes into mutate. Okay? So always try to pull apart what the compiler is doing so that you can actually know what's going on. Yeah. If you put it into a POSIX or a date format, you would have to give it a month and day. So, you could. It would always end up being, January 1st of whatever year, though. Yeah. There's an alternative way that you could have done this also, just to show you. You could have done repeated, digit, and 4. And that would have given you same sort of, there we go. Yeah.
Is probably a question. Some of the dates in there were like 2003A, 2003B, so from the same author.
Mm-hmm.
Is that not because doing it that way I couldn't pull out the
This should have still worked unless oh wait, I just did that. I did that weird. Let me fix this first. There we go. That would still work unless you had also done that. If you had added the close paren, then it would not have worked. If you didn't, it should have worked. Because all it's looking for is an open paren and then 4 digits. So if there's an A or a B or whatever after that, it shouldn't matter. Oh, I didn't say it, did I? Yeah. No, yeah, because the A and B just represents that somebody made a citation, and then there's 2 citations of the same author in the same year, but it's a different paper. So that's not part of the publication year. Yeah. Didn't know there would be APA style quizzes in here, did you? All right. So we're gonna. Did I just mess this up again? Oh, this should be. Yeah, it's working. No, it's not working. I'm not sure why it's flagging me right now. Apparently added an error when I was doing this somewhere. Incorrect number of dimensions.
So not what you're trying to do it with as numeric.
I think it's there. Yeah, that was it. So it's always parentheses. Parentheses are a horrible nightmare. So anytime, and the way I just showed you previously too is a really good way to code it and to only put it into one line after you're confident it works. Yeah, to use the drill down so that you can see where all the opens and closes go. It also very helpfully, I don't know if you've seen it, it highlights the parenthesis that it's actually attached to. So you can see that moving right there as I highlight different parentheses so that you get a little bit better sense of which one you're working on. That's a really useful visual clue when you're trying to figure out what's wrapped around what. So yeah, right now this collapses, that's where I got thrown off. So this collapses, or this closes repeated, this closes captured, this closes string match. Then because string match is closed, I can call for a column, and then this closes as numeric around it. And then this one closes mutate. Okay. So we'll go, I almost did it again. All right, 19. We're going to get a little more room here. Okay, line 19. Create a new variable called page starts that contains the first variable of each citation. All right, this one might be a little weird. How'd you do this one? One or more digits. What was that? Quote hyphen. Ah. So one or more digits and then a hyphen. That would be most of them. Yeah, I think that would work. So if you do it that way, the downside is if you have if you have one or more digits and then a hyphen for any reason in a title, that would also be captured. The slightly safer way to do it, I would do, is also to just follow this with another one or more digit. Just as a way to add that kind of extra layer of check. Yeah. So in those, yeah, that should be a pretty small number, though, I would hope. So the basic format is you're trying to capture number dash number. You're also trying to capture the first number dash number with string match. You could, if you were really being clever about it, use string match all and then match only the last number dot number. That would probably be the safest way here. So if you did a string match all, you would get a list of all the possible matches, and then you could return only the final item in that list, the object at position length. That would work. So yeah, all of this is exactly the kind of thinking you should be doing with regular expressions. So good. Yeah. So this should, actually, let's try it. Page search. Yep, I got a close one or more, close string match. There we go, that should have worked.
So I added optional spaces in there just in case.
That's good too. So again, the kind of the purpose here is really just to get you to start thinking about kind of the complexities of these regular expression operations. Because there are many situations, like it's never going to be perfect, like ever. So if you've ever seen data sets where they are pulling information from the internet at random, these kind of errors are everywhere. The goal of this part is just to minimize it as much as possible. Think about it in terms of reliability, because that's really what this is. If you are capturing what you mean to capture more than 70, 80% of the time, that's a 70 or 80% reliability. Like you're capturing the intended thing that percentage of the time. So in real published work, if you ever need to do this kind of thing, like that is your reliability estimate. Is like how often did it work? Yeah. So let's see. Oh, these are badly formed citations though. These are not. These don't look like APA to me. Yeah, you can't. Yeah, you can only chase errors to a certain degree. As soon as I start getting, let's actually try to look at one of these. There we go. That's not a correctly formed citation. It isn't either. It's actually still getting it, but those are still not APA. Definitely not APA. Definitely not APA. Actually, that's still not getting the full thing because those quotes in there. Yeah. Still not APA. That one is, but it got the one, so it worked. So, yeah, I think this is working for any case where they have an APA formatted citation. One approach that you could have taken while developing these two is to create a small tibble of like 5 citations that you know are formatted correctly, and then test on that rather than trying to chase all these down. Yeah, if you wanted to capture single-page articles, you would probably want to capture number, optional dash number, period, optional DOI information, end. That would be the safest way to do it that way if you decided you wanted to capture those two. This is why if you do this in the real world, this can take a lot of time. So it all depends on the hit rate. With this, I'm pretty confident for the APA style citations were over about 70%. We're probably closer to 80 or 90, but this gets most of it, and that's really what you're aiming for. Mutate. Line 20, perf ref, which gets true for any citation where there's a reference to the word performance, regardless of capitalization, false where there's not. This one's a little easier. So, how do we do it? Are we still using strmatch? No, what are we using? strdetect. We're still looking at cite though. Maybe. How'd you do this? For what? For cite?
Yeah.
Yep. Oh. There we go. And you can very easily verify this one's working by doing what we were just doing. By just searching, reordering by trues and falses and seeing if it's in there. That's it. That's the whole expression. Yeah, I mean, where you start thinking of in terms of regular expressions is really the exceptions. Like you're not thinking so much about the standard cases. So it's like, is there any situation where X could be true? That's what you start worrying about. But yeah, it'd be really unlikely. Oh, S string to lower just converts the entire citation into all lowercase. So all we're doing here, and actually we can see it really easily. Mutate lower equals string to lower cite. And you can just see all it does is it converts the whole thing into lowercase. I think to lower would probably work here too. Yeah. So to lower is the base R function. We had that a few weeks ago in data camp. Then str underscore to lower is the stringer function that does basically the same thing. Yeah. Okay. We're at 21. Okay, the title. Title's a little bit harder. Not because of the beginning, but because of the end. Figuring out where a title stops was the real challenge here. So we're going to do CTR match again, cite. What did you try? So in APA style, citations universally occur after the year. So if we have close paren, dot, space, and maybe you can make that space optional, doesn't really matter. We've now started wherever the title is. So who got that? You, yeah, okay. So the start part is fairly straightforward. As long as you know that rule, as long as you know that there will always be parentheses, that close paren, dot, space, or optional space if you're being tricky with spaces, and then words. So the question then is, what do we do in order to capture all of the words until something else? How do we do that? Negated character class. And what are we looking for? A dot. Dot. So that's the first part of building this. This would specifically look for any one character after the space that is not a dot, but that's not what we want. We want a slight modification of that, one or more of those things. In a lot of parentheses now. If you do a period in quotes, yes, because a period in quotes is any character in regular expressions.
Yeah, that's what I did not.
Yeah, you would have to use a backslash dot if you put it in plain text. Yeah, so yeah, any time that you need special characters, this is where Rebus really helps a lot. Okay, so we got one or more, and then we need to capture that too, right? So we need this whole expression, capture one or more negated character classes. We need to find the end of string match so that we can add a 2. And I think that's it. Yep, there it was. Now, this is an interesting point where we can try to look and see what this looked like in regular expressions. That one, maybe? There you go. So if you wrote this in a raw regular expression, you would have ended up with this. And for some people, that just makes more sense than the Rebus. I would not write that, personally. I would probably do it, even if I did want to write a regular expression, I would write it in Rebus and then convert it into a regular expression. So this is the same thing, and you can see all the pieces. There's a literal closed paren, a literal dot, then a space, using the space character class. Then a capture mark with those parentheses, then a negated literal dot, and the plus indicates one or more. So it translates directly into that. But it's just, if you actually write this yourself, it's real easy to miss just one slash somewhere, and it can be real frustrating. Okay? So if you wrote it as an actual character class, you would end up with, or regex class, you would end up with that. If you wrote it as Rebus, you would do something like that. So the reason why journal title is worse is because journal titles had to be distinguished from book titles, and book titles might optionally have parentheses with additions and other information after them. So that is why I did not ask you to do journal titles, because that ended up being insanely complicated. And I tried for like an hour to make that work in an easy way, and I couldn't do it. So if I can't do it in an hour, I just no. So this one, once you get these two anchor points in mind, that there's always going to be a closed paren, dot, space, and again, you could do optional there. And there's going to be some number of characters until a dot. And last time I even stopped, if you remember, I said, don't use one or more any car, because it's not what you think it is. That's why we talked about that. You don't want one or more any car, you want to go until a specific character. That's the one or more negated class. Okay? Does that make sense to everybody? Yeah. So this kind of reversal of thinking is super, super important. Oh yeah, you're right. There's one right there. Yep. So you could have done an optional period closed paren. Yeah, that's good. That's a good catch. So line 22. So this one I wrote as many needed at the end because this is one where I think it's really helpful to string them out where you can see them. And there's also quite a few things you might need in order to capture that name. Because what we basically, in order to capture a first author, what you basically have to do is say, well, what I want back is the last name, the comma, and the initials. But there could be any number of initials, number one. And there could be, well, not any number. There could be either 1, 2, or 3. realistically speaking. And then there could be, at that point, either a comma or a space and an open paren, depending if there's more than one author, or there could be an ampersand. Depending if there is more than one author, how many authors there are, that all would change. So as long as you got most of the way through this citation, then that's fine, because this is the most complicated on here. But let's try it out. First author equals string match, cite. Okay. So we'll start off easy. Start. So the first thing you need is going to be, let's ignore capture for right now. What is the first thing that you need? Yeah, we would need a capital letter. We don't necessarily need to differentiate between capital and non-capital here, though. But yes, that is true. Some number of letters, right? So we might do one or more alpha to indicate that letters are being used. So capture all alphabetical letters, whether they're capital or lowercase, upper or lowercase, up until that stops happening. That's what that means. After that, there's going to be a few different possibilities. You could, except it wouldn't capture hyphenated names. Oh, good. Yes, then for this, that would work. Yeah, I tried to add as many parameters to make this as simple as possible, but man, there's so many use cases here. So what comes next after our last name? Comma. After comma, might be a space. After that, yep, a letter will come. A dot. Put all of that in one or more. Yeah, let's do it that way. One or more alpha and dot. Oh, and space here? Oh, yeah. And I might make that also an optional space. Okay. Where are we in the expression right now? We have letters, we have a comma, maybe a space, then one or more alpha dot optional space. So they have at least one first initial. They always have a first initial. They may have more initials. And at this point, we are after the final dot, theoretically, or space, after a bunch of initials. So now what? Optional comma. Let's actually just work with what we have right now and see what it looks like. We're going to do... Yeah, make sure we close it correctly. Is that it? Okay. Nope. Nope, we're missing something. Oh, am I bracketing wrong? Oh, yeah, you're right. No captures yet. So if we go over here, where are we? That's not valid APA. That's a lot of initials. Also not valid APA. We're getting all the initials that are there. JU. DI. Are we getting spots that have both spaces and non-spaces? Let's look at some of the ones that aren't working to see why they're not working. This one's not. Has a hyphenated name. That one's not working. Hyphenated name. If you were doing this for real, you would start to be worried about hyphenated names at this point. Looks like we have it. Anybody use an alternative solution? Anyone use a more complicated solution? Well, let's see if you had tried, again, against my recommendations, to do this all by hand. Well, we'd end up with that. Instead of alpha character class, you might have had non-digit or the letter in regex. Does the same thing. But that, yeah, I find this expression a lot easier to read than this expression, personally. There we go. So yeah, and we went to line 27, so that's not too bad. But yeah, that's it.